Hi viewers, I'm Emmanuel Johnny. In today's video, I want to teach on the topic calculus, but this one is pre-calculus. And now we are going to be learning in this video how to find the domain and range of functions. In case you're just coming across my video for the first time, please like, share, subscribe, and comment. Now, if you look at the Math 121 exercise, Unit 1, you discover that there are 3 questions there, which has to do with your ability to find the range and the domain of those functions. So I'm going to be taking them one after the other. So this is the first question in that manual. And the question says, find the domain and range of the function. Now, when we say domain and range, what do we simply mean? In a layman's sense, let me put it this way. If I say y is equals to 2x plus 3, this is a function, y is equals to 2x plus 3. I want to find the domain and the range of this function. How do you find domain and range? Question is, what do you even mean by domain and range? Look at it. If I say let x be equals to 1 and 2, then with the values of x, I can obtain the values of y. How? Anyway you see x, put 1. So y is equals to 2 into x is 1. So put 1 there, plus 3. Meaning that y is equals to 2 times 1 is 2 plus 3, which is equals to 5. So it means that when x is equals to 1, then y is equals to 5. The value of x, which is 1, I put into this function is called the domain. Whereas the answer I obtain, which is y being equals to 5, is called the range. So that means that domain is the set of input values of x that makes a function defined. And range is a set of output values of y. Input, so you put x into the function and it outputs 5 in where? Y. So range is the output values of y. Okay, with that understanding, let us now state the domain and the range of this particular function. Now this function here, g of x equals to root 2x plus 4, is actually a root function. There is how to find the domain and the range of a root function. This is it. I have to find the domain. Now the function is root 2x plus 4. Please note that as far as root function is concerned, mathematically speaking, if you punch your calculator, square root of 4, the answer is 2. And square root of maybe 16, the answer is 4. But if I punch square root of minus 4, your calculator will tell you math error. You can try that. It doesn't exist. Even if I say square root of minus 16, mathematically it does not exist. That is only on the real value function of real variables. But this thing can exist in another branch of mathematics, which is complex number. So that means this can exist in the complex plane. But in real value functions, this thing does not exist. So punch your calculator, it doesn't exist. Meaning that if I'm looking for domain, which is a set of input values of x, we are saying you must be careful not to include values of x that will make this function not to be defined. In other words, not to exist. So, how do we find the domain of root function? With this explanation, that means that what you must find inside the square root sign can only be positive numbers and 0. Square root of 0 must give you 0. That means if you put 0, it will exist. If you put positive numbers, it will exist. But if you put negative, it doesn't exist. Meaning that for this function to exist, what is inside, which is 2x plus 4, must be greater than or equals to 0. So that means that 2x plus 4 must be greater than or equals to 0. Once you define that, the next thing is for us to find the values of x. So it means that this is linear inequality. What do? Collect like terms. So that means that 2x is greater than or equals to, plus 4 will cross and become minus 4. Please, we say that 2x plus 4 must be greater than or equals to 0. That means the values inside this root sign must be numbers which are 0, or which is 0 rather, or numbers that are greater than 0. Of course, you know that in the number line, if this is 0, and then numbers greater than 0 are positive numbers till infinity, and numbers less than 0 are negative numbers till we keep going to negative infinity. So from here, let us find the value of x. Of course, you divide both sides by 2. If you do that, x is greater than or equals to 2 goes into minus 4. That will give you minus 2. So that means that x is greater than or equals to minus 2. This minus 2 here, we call it the critical point. So you can now use this minus 2 and put it on the number line. Put it on the number line as this. Okay, this is minus 2. Okay, so it has divided this number line into 2, whereby this is positive infinity and this is negative infinity. So with this, we can now obtain all the values that will satisfy this function, and then carefully removing all values of x that will make it undefined. So what do? We now test. There are 2 regions there. So pick any value here and substitute into the function. Okay, let's say g of x. Now let's say assume that x is equals to, please, immediately after minus 2, what you have here is minus 3. So let's pick a number here, minus 3, and substitute into this function. That means at x equals to minus 3, it means that g of minus 3 will be equals to square root of 2 into minus 3 plus 4. This means g of minus 3 is equals to square root of 2 times minus 3 is minus 6 plus 4 plus 4. So that gives us square root of minus 6 plus 4 is minus 2. So we can see we don't have square root of negative numbers. It means that minus 3 does not satisfy this function. So it means that since minus 3 does not satisfy it, it means that no value in this range will satisfy it. You can pick minus 4, minus 5, none of them will satisfy it. So this point does not satisfy it. Next thing you do is you pick another point in this boundary from minus 2. Immediately after this, the next thing here is minus 1, 0, 1, 2, and so on. So let's pick a number, say minus 1. So that means that at x equals to minus 1, g of minus 1 will be equals to, put it in the function, square root of 2 into minus 1 plus 4. This is equals to square root of 2 times minus 1 is minus 2 plus 4. That gives us square root of minus 2 plus 4 is 2. That is positive. It means that this region satisfies it. Then the last thing you do is to check at that critical point if it satisfies the function. So that means that at x equals to minus 2, it means g of minus 2 will be equals to, what do? Put it in the function, square root of 2 into minus 2 plus 4. So this is equals to square root of 2 times minus 2 is minus 4 plus 4. And minus 4 plus 4 definitely is 0. So this means square root of 0, which is equals to 0. It means that at this critical point, the function is defined. So that means that we need this point as well. So now, in conclusion, how do we find the domain of this particular function g of x, which is equals to square root of 2x plus 4? So we now say that the domain of the function g of x is, look at this, from minus 2 to infinity. It means that any number you pick in this region will satisfy this function. For instance, pick minus 1 like we have tested, it works. Pick 0, it will work. Pick 1, 2, 3, till infinity, it will work, including minus 2. Let's assume that we put minus 2 and it gives us a negative value. Let's assume minus 3. Then we would have said this point is not inclusive. But since it is inclusive, how do you now write the domain? This is what you do. The domain of this function is from minus 2. So we use a square bracket till positive infinity. You close it, you open it like this. Of course, you cannot close infinity because it keeps going. So we use an open bracket. But this one, the square bracket here, means that 2 is inclusive in the solution set. So it means that the domain of this function, root 2x plus 4, is from minus 2 to positive infinity. Why do we use square bracket? Because minus 2 is inclusive. But if it were not to be inclusive, then we would have used an open bracket like this. Okay, so this is the domain of this particular function. The question asks for domain and range. If this is the domain, now how do we find the range of root function? Please, I am only providing solution to this question, but I'm also going to provide a full teaching on domain and range of functions. So we'll look at several functions and understand better. But for now, I'm only trying to solve a problem. Now, let me use this. To find the range of a root function, what do? We find the range of root functions from the domain of that particular function. This is very, very important. So which means that even if you are asked to find the range of a root function directly, remember this one says find the domain and the range of this root function. So even if I was asked to find the range of this function without being asked the domain, it is important to note that the first thing you must find is the domain. It is from the domain you get the range of the function. So even if the question was find the range, that means I would have still passed through the same process to find the domain first. So it is from the domain you get the range of root functions. So how do you do that? The range now is what we want to find. So in getting the range of root function, this is what you do. From the domain, the value here, this first value here is the minimum value. The minimum value. Then the last extreme number here is the maximum value. So this is the minimum value of the function and this is the maximum value of the function. So what do? You substitute the minimum value into the function and also substitute the maximum value into the function. I hope that's pretty cool. Let's go. I pick the function. So that means I'm going to find g of minus 2. That is the minimum value put into the function. So g of minus 2 will be equals to square root of 2 into minus 2 plus 4. That means that g of minus 2 will be equals to square root of minus 2 times minus 2 is minus 4, then plus 4, which is square root of 0. That means that g of minus 2 is equals to 0. Of course, square root of 0 is 0. Good. Next, you substitute the value of the maximum value. Yeah, so let's do that. And the maximum value is infinity. So that means I'm going to find g of infinity. In other words, put infinity into the function. Anyway you see x, put infinity. So that will be square root of 2 into infinity plus 4, which is equals to square root of 2 times infinity. Infinity is actually a very large number. So carry 2, multiply with infinity. 2 multiply a very large number, it will still remain that large number. Meaning that 2 times infinity is infinity plus 4. So here we have square root of infinity plus 4. that is, carry 4, add in a very large number, you still get 4. You still get infinity. So, infinity plus 4 is infinity. Square root of infinity will still give you infinity. So that means that g of infinity is equals to infinity. Alright, the minimum value, which is minus 2, gave us 0. And then the maximum value, which is infinity, gives us infinity. So it is from here we can now see or obtain the range of this particular function. So it means that the range of this particular function g of x is equals to, of course you know it's a root function, from 0 to infinity. In other words, these are the values this function will output when you substitute these values of the domain. So the range is, of course, a root function also outputs 0. So you can see it is from 0 to positive infinity. So that is the range of the function. So in conclusion, the domain of the function g of x is minus 2 to infinity, and the range of the function g of x is from 0 to infinity. Alright, so that is how you find the domain and the range of this particular root function g of x is equals to root 2x plus 4. Please subscribe, like, share, and comment. Thank you. Okay, so this is another question from the manual, which is still unit 1. We want to take a look at. Now you have to find the domain and range of the function g of x is equals to square root of 4 minus x squared all over x minus 1. So I'm going to go straight to the point. Like I said, it's just to provide solution to the problem. So the function is g of x equals to root 4 minus x squared all over x minus 1. We want to find the domain of this function. Now, there are things to look at. First of all, this is a rational function. The numerator is a root function, and the denominator is a normal linear function. But the fact remains that for a root function to exist, please note, like I said in the previous video, that what is inside can never be negative. It must be from 0 to positive numbers. Number 2, for a rational function to exist, the denominator can never be 0. For instance, just carry a calculator, punch any number, say 2 over 0. The answer is, automatically is, you will see the word undefined. So we say the fraction is undefined if the denominator is 0. So we can use this to represent it. Now, so this question is a bit critical in the sense that, first, the denominator can never be 0. Also, the numerator cannot be negative. In other words, you cannot have the square root of a negative number. So we must put all that into consideration. Now let's start with the numerator. So the numerator is a root function, that is root 4 minus x squared. For this function to exist, the function inside, which is 4 minus x squared, must be greater than or equals to 0. I have said that in example 1 already. So with that understanding, let's solve for the values of x. Of course, this is a quadratic inequality. Anytime you have power 2, that is quadratic. So let's collect like terms. Minus x squared is greater than or equals to plus 4 will cross. to become minus 4. Now, the coefficient of x squared is negative. Multiply through by negative. If you do that, the inequality sign will reverse. So if I multiply this by negative, I'll have x squared. Then because you're multiplying through by negative sign, this inequality changes or reverses from greater than or equals to less than or equals to. Of course, you multiply this by negative, it turns to positive. Now, x is less than or equals to square will cross this sign to become plus or minus square root of 4. If you learn quadratic equation, you will understand why that happens. So that x is less than or equals to plus or minus 2. Is less than plus or minus 2. So these are the values of x, which we call the critical points. Next, pick the denominator, which is x minus 1. Look at it. And you know that for this function to be defined, the denominator can never be 0. So we say x minus 1 cannot, that is, say, is not equals to 0. It cannot be. Because if it is 0, it becomes undefined. So at this point, I can say that my x is not equals to 1. Of course, if you put 1 here, 1 minus 1 is 0. So x cannot be 1. But this solving now gives us the critical points. So how many critical points do we have? 3. The first one here is plus 2. Next one is minus 2. And then the other one now is 1. These are the 3 critical points we have, which we'll make use of in defining the domain and range of this function. So let's go. First of all, you now draw the number line where this is negative infinity. This point is minus 2. This point will be positive 1. And this point will be positive 2. And then in positive infinity. Of course, in the number line, you have negative. Then after that, this is 1. This is 2. You have minus 2. Look at it. Plus 1. Look at it. Plus 2. Look at it. And then positive infinity. So the next thing we are going to do quickly is to test the point and know which of this region will satisfy this function g of x. So let's test. This is minus 2. We'll pick a point here, say minus 3. Remember, after minus 2 is minus 3. So g of minus 3 will be equals to, anyway you say x, you put minus 3. So that will be square root of 4 minus into x is minus 3 raised to the power of 2. Okay, all over minus 3 minus 1. So that means that g of minus 3 will be equals to, please note, minus 3 square is positive 9. So 4 minus 9 is minus 5. So you have square root of minus 5. All over minus 3 minus 1 is minus 4. So for the fact that this is a negative square root, it means that it does not exist. Remember, we've said that the square root of negative numbers does not exist. So this point is not defined. Let's pick a point in this region now between minus 2 to 1. Here I can have minus 1, I can have 0. So let's pick minus 1 if you like. So that means that g of minus 1 will be equals to square root of 4 minus into minus 1 square all over minus, okay, x is minus 1. So minus 1 then minus 1. Okay. That will give us minus 1 square is 1. So 4 minus 1 is 3. That means root 3 all over minus 1 is minus 2. Of course, for the fact that this is positive, it is defined. So that means that this region is defined. We have 1 and 2. Of course, you don't have, between 1 and 2, nothing to pick there. But here you can pick a number, say after 2 you have 3. So let's pick 3. If you pick 3 and substitute here, 3 square will give you 9. 4 minus 9 will give you minus 5. So this region is not defined. Now the next thing you check out for is the critical points themselves. Okay, so without wasting much time, you understand what I'm doing. So I'll just explain it without writing. Let's pick this critical point here, -2. So that means that g of -2 will be equals to what? Let's go. Put -2. -2 square will give you 4. 4 minus 4 is 0. So that means you have square root of 0 all over, what we picked was -2. Okay, -2. So -2 minus 1 is -3. Of course, square root of 0 is 0 all over -3. 0 divided by anything is 0. So it's defined at that point. Let's pick the critical point here, 1. Put it there. 4 minus 1. No, 1 square is 1. 4 minus 1 is 1. Square root of 1 is positive. But 1 minus 1 is 0. It makes it undefined. So this point is not inclusive. Let's pick the point 2. 2 square is 4. 4 minus 4 is 0. That means that g of 2 will be square root of 0 all over 2 minus 1 is 1. Square root of 0 is 0 over 1, which is 0. So it therefore means that this point is defined. So in the light of that truth, how do we now pick the final answer, which is the domain of this function? Don't forget, it is from negative infinity to -2 to 1 to 2 and to positive infinity. So picking the final answer, this region is defined, this is not defined, this region is defined, and of course you see this region is defined as well. So that means that the domain of this function is from -2. Of course, -2 is involved. So that means it is closed. -2 to 1. From -2 to 1, so you have -2 to 1. But remember, 1 cannot be included in the solution set, because if you put 1, it makes it undefined. So it will be open to show that 1 is not inclusive. Alright, we now have from 1 to 2. 1 is not inclusive, but 2 is inclusive. So it will be open. And now from -2 to 1 and union, that is and, from 1 which is not inclusive and then to 2 which is inclusive, so it is closed. -2 is inclusive, that's why you have this closed. From -2 to 1. 1 is not inclusive, that's why it is open. And from 1 to 2, 1 is not inclusive, that's why it is open. And 2 is inclusive, that's why it is closed. So this is the domain of this particular function. Now the question is, how do we find the range? It's very simple. Okay, I can clean this side. In finding the range, look at the function g of x is equals to √4 minus x squared all over x minus 1. What do? I can test the values here. Look, I have -2. So if I put -2 in this function, what will I get? Remember, range has to do with the output values of y. Okay, so let me find g of -2. That will be, if I put -2 here, that will be -2 squared is 4. So 4 minus 4 is 0. Square root of 0 is 0. That will be 0 all over -2 minus 1 -3. Of course, 0 divided by anything is 0. So it outputs 0. Okay. Of course, I don't need to put 1 because already it will make the function undefined. So I skip that. So that means that the range Of course, I pick -2 from the negative region. So that means from negative infinity to 2, it outputs 0. So that means from negative infinity to, what did the -2 output? It outputs 0. So it will be from negative infinity to -2 output 0. From negative infinity to 0, 0 is close. And coming here, if I put 1, of course, you know it will not be defined. It will be undefined. No need to test that. Pick 2. Put it into the function. 2 squared is 4. 4 minus 4 is 0. Square root of 0 is 0. So that means that g of 2 will be 0 all over. Put 2 minus 1 is 1. 0 divided by 1 is 0. So it means that the range will be, look at it, 2 is defined. So that will be 2 to positive infinity. That is from 2 to positive infinity. And don't forget, 2 outputs what? 0. When we put 2, it outputs 0. So that will be from 0 to positive infinity. So you have positive infinity. So in a nutshell, the domain of this particular function is from -2 to 1 and from 1 to 2. -2 is inclusive and 2 is inclusive, hence the square bracket. And then the range is from negative infinity to 0 and from 0 to positive infinity. This is the range of this particular function. So once again, I remain Emmanuel Johnny, your mathematics video tutor. Please don't forget to like, follow, share, and most importantly, subscribe to my channel. And don't forget, subscription is free.